So in this we can see what is the depletion mode of operation of a MOS capacitor. So for this depletion mode we need to apply positive voltage at the gate. So a gate voltage is made positive, then this positive voltage will repel this, the positive voltage will cause a positive charge in this metal, and to compensate that here we need a negative charge. But if you are applied a positive charge at the gate, we can see that this material is p-type substrate, the majority carriers are holes. So this positive voltage repel this holes and pushed back into the bulk or in this substrate. So they are near the surface, the holes are repelled to this surface. So what will happen, this here becomes a layer having uncompensated acceptor ions. So this leaving of this positive charge to this region will cause a negative uncompensated acceptor, negative ions, that is called uncompensated acceptor ions here. So we can say that, so due to this uncompensated acceptor ions there should be a depletion layer formation. That's why this mode is called depletion mode of operation. So we can say that the deposition of positive charge on the gate requires compensation by negative charges in the semiconductor. The negative charge in a p-type semiconductor arises from the depletion of holes from the surface. So the holes from the surface depleted, and due to that there is an uncompensated acceptor ions, it has negative charge. So we can say that this layers counters the positive charge on the metal, and we can say that it keep increasing till the gate voltage is below threshold voltage. So we need to apply a gate voltage which is less than the threshold voltage. Threshold voltage means that voltage, the minimum voltage needed to make a channel in case of enhancement MOSFET. So we can say that, so in this diagram we can say that it can be seen that the band bent downward. So we can see that the bands are bent downward. So we can say that this is, here we now have accept a negative charge. So to indicate that the bands are bent downward, because we can see that this EC is now more closer compared to previous in case of this is the accumulation. So in case of accumulation, EC is far away from this Fermi level, but now EC is somewhat near to this Fermi level. That shows the accumulation of negative charge in this surface. So we can say that this EC become more closer to Fermi level, which indicate the presence of negative charge at the SiO2. This is Si and this is SiO2. So that interface we have more negative charge. So we can see that the tilting in the outside band account for the presence of electric field, that is from positive to negative. So the tilt is in the same direction of electric field. So that is the case of depletion mode of operation. So we can say that this depletion of holes, when we applied a positive gate voltage, the depletion of holes will cause a uncompensated ion acceptors, so that have negative charge, that is increased electron concentration, indicating that band bend downward near the semiconductor surface, that is EI closer to this, EI also bend downward, that means EI now moving closer to EFS. So that is the condition for depletion. So we can see that for a depletion mode, for p-type substrate we should be greater than 0, and for n-type substrate this depletion mode of operation we should be less than 0, and it is should be less than the threshold voltage also.